Hello, welcome to GMAT GENIE number system part 2. Today we will be looking at remainder theorem in number system. Before we start off with the number system, that is remainder theorem, please note down the website address of GMAT GENIE. It is www.gmatgeniescore.com and our email ID is gmatquant@gmatgeniescore.com. So let's look at remainder theorem in number system today. What is remainder theorem? Remainder theorem states that remainder of any expression, that is a times b times c times d upon whole thing upon m, is same as remainder of the expression, which is a remainder times b remainder times c remainder times d remainder divided by m. So what does it really mean? So let's say you have a very large expressions where you have numerator and denominator. Okay, you are trying to divide by the value which is there in denominator and find out the remainder of that complete expression or a fraction. If suppose you have a very large number on the numerator and let's say there are multiplication signs between two numbers or between three numbers on the numerator, when you try to multiply that, it becomes very large number, and then you again have to divide by m to find out what is the remainder. It's going to be very complicated and complex affair. So remainder theorem comes out as a very handy tool to help you out and figure out what is the remainder for such an expression when it's divided by m. So what it says that remainder of any expression where you have multiple terms as within multiplications on the numerator, and then you divide that by let's say another value called m, then the remainder is same as the remainder of the expression, that is AR times BR times CR times DR upon M, where AR is the remainder when A is divided by M. Similarly, BR, CR and DR are the remainder when B, C and D are respectively divided by M. So you don't really need to multiply A with B, with C, with D, and then the whole thing you need to divide by m. You don't really need to do all that. All that you need to do is divide a by m and find out what is the remainder. Similarly, divide b by m and find out what is the remainder. Like that you go on doing for all the terms which are there in the numerator by m. So to illustrate this, we have taken one example here. Okay, let's say we need to find out the remainder of 61 times 78 times 94 when this particular expression is divided by 11. What is the remainder I get? One way to do it, you multiply 61 with 78 and then whatever you get, you multiply that with 94. So it's going to be time consuming. Not only that, it's going to be large number, and then again you divide that by 11 and find out what is the remainder, right? That is going to be time consuming process, especially in an exam like GMAT or CAT. You don't get so much of time to figure it out. So what is the quick and easy way to solve this problem? What you do is you divide individual number, that is 61 with 11, and find out what is the remainder. When you divide 61 by 11, you get a remainder of 6. Similarly, when you divide 78 by 11, you get a remainder of 1. Like that, when you divide 94 by 11, you get a remainder of 6. So what you get on the numerator is 6 times 1 times 6, whole thing upon 11. Now, whatever number that you see on the numerator, it is very easy to handle. 6 times 1 times 6 is 36. 36 upon 11. Again, you divide 36 by 11 and you can easily figure out what is the remainder. Here in this case we get a remainder of 3. So the remainder of 61 times 78 times 94 when divided by 11 is 3. You can also check. You can multiply these three numbers and then you divide by 11 and figure out. You will find out that the remainder comes out to be 3. So it's a very easy and nice way to solve any such expressions where you have a value on the numerator and a value in denominator, and you are supposed to find out a remainder of such an expression. You can use remainder theorem. Now let me actually work out a problem for you so that you have a better understanding about remainder theorem. Let's take a number 6689 times 745 times 523, and we are trying to divide by 8, right? If you try to multiply 689 with 745 and then again whatever value that you get you multiply with 523, it's going to be a large and very huge number, and then again you have to divide by 8 to find out the remainder. It's going to be very time consuming. So what you do is individually you divide 689 with 8 and find out what is the remainder. Similarly 745 by 8, find out the remainder, and like that 523 by 8 and you figure out the remainder. So if you divide 689 by 8, you get a remainder of 1. Then if you divide 745 by 8, you get a remainder of again 1. And then 523 by 8, you get a remainder of 3. So on the numerator, you get a value of 3, right? And on the denominator, it is 8. Remember, you don't strike out denominator with some value in numerator and make it a smaller number. In this case, you don't strike out 8 by dividing by 2. Obviously, you don't have 2 on the numerator. None of these terms on the numerator are even terms. So obviously here we can't do that. But suppose instead of 689 you had 690. The easy temptation would be to divide 690 by 2 and you get 345, and then you divide denominator, that is 8, by 2 and you get 4. You can't apply remainder theorem using this method. In the remainder theorem, make sure that the denominator remains the same, which is the original value. Here in this case it is 8, right? So as you can see here, the remainder is, you get 3 on the numerator, right? You can't go further than this, right? So the remainder value of the expression, that is 689 times 745 times 523 upon 8 is 3. So remainder theorem comes out as a very handy tool for people who are appearing in competitive exams like GMAT and CAT, where they don't have much time and they have to do it quickly, and that way remainder theorem is a very handy tool to address or to attack these kind of problems. Thank you. We will continue with the number system, some more problems in the next video or tutorial. So keep looking at this space. Thank you.